Let's see if we can figure out what word goes in this blank. Cations are blank, then the neutral atoms from which they are derived. Let's look at the example and see if we can figure it out. Here we have a lithium atom, which has the electron configuration 1s2, 2s1. This lithium atom has 3 protons and 3 electrons, and it's a certain size. Lithium is going to want to lose 1 electron so that it can have the same electron configuration as helium, and therefore this 2s electron has disappeared completely. This lithium ion has 3 protons and only 2 electrons, so the outer energy level has gone away, and the lithium ion is clearly smaller than a lithium atom. And this is true generally for cations. The way we rationalize this, we might say a couple of things. We might say, firstly, that orbitals might be completely vacated, as in the case of the lithium ion. And we always say that electron-electron repulsion decreases. In other words, the electrons that are surrounding this nucleus are tending to repel each other, and they push each other away, and they are therefore maintaining a certain size of cloud because they're being held in by the protons from the nucleus, but they're tending also to push each other away. If we lose an electron, that electron-electron repulsion, that tendency to repel, is decreased because there are fewer electrons to do that. So, anytime you lose electrons, anytime a cation is formed, electron-electron repulsion always decreases. How about these 3 species? This iron atom on the left has 26 protons and obviously 26 electrons. The iron 2 ion has lost 2 electrons, and the iron 3 ion has lost 3 electrons. Clearly, anytime we lose an electron, that buzzing cloud of electrons is going to shrink in size because there are fewer electrons to push each other further and further apart. So in terms of size, we would predict something like what is shown at the bottom. Now what about anions? How do they compare in size to the neutral atoms from which they are derived? Well, a chlorine atom has 17 protons and 17 electrons. A chloride ion has gained 1 electron, and so has 18 electrons. In other words, a chlorine atom is going to have a certain size, and a chloride ion, if we throw an extra electron in there, that cloud of electrons is going to increase in size. So anions are going to be larger than the neutral atoms from which they are derived, and that's because there is more electron-electron repulsion anytime you add electrons. You can imagine this buzzing cloud of electrons. Oh, they are buzzing like flies. And if I throw an extra electron in there, what happens to the size of that buzzing like flies cloud of electrons? It foofs out. That's a technical term that I made up. More electron-electron foofage. That electron cloud foofs out. Now, don't use the term foof or foofage on a written portion of your AP chemistry exam. Use instead the term electron-electron repulsion. Incidentally, I'm not exactly sure how to spell foofage, but I know it's a real thing. The term you want to use is electron-electron repulsion, although the term foofage is just cool. An isoelectronic series is a list of species having an identical electron configuration. These species here all have 10 electrons. But because they have different numbers of protons, they're not all going to be the same size. On the left, the nitride ion has only 7 protons, and on the right, the aluminum ion has 13 protons. With equal numbers of electrons, clearly the aluminum ion is going to be smaller. How about these? Which has the largest radius? We've got the rubidium ion, the strontium ion, and the yttrium ion. We can find from the periodic table and their charges how many protons and electrons these have. And we find that they all have the same number of electrons. But yttrium has the most protons. clearly those 36 electrons are going to be pulled a little more tightly. So of these, I would have to say that the rubidium ion has the largest radius. Final thoughts on trends in ionic radius. 1. Cations lose one or more electrons and are smaller than parent atoms. The more electrons they lose, the smaller, in terms of volume, they are. 2. Anions gain one or more electrons, and so are larger than parent atoms. With each electron gained, the volume increases even more. And 3. Because electrons have only a very tiny mass, the mass of any ion is nearly the same as that of its parent atom. And you can see in this picture here, on the left, we have atoms, the silver color, and then the ions, which are in red, and they are smaller, and all of those are cations. On the right, the gray, or the silver, represents, again, the neutral atom, and the blue represents the size of the anions, and you can see that the anions get larger than the parent atoms.